Hi, and welcome back to Serial Killers, the podcast that is supposed to cover a different pest, disease, and weed of arable crops every week. However, this week we're going back to an old favourite in blackgrass. Well, if you're an arable farmer, we probably wouldn't call it an old favourite, probably an old foe. And so for the non-farmers out there who don't know what blackgrass is, it's a pernicious weed that once it gets into a field, it spreads rapidly because it's got very small seeds that it produces thousands of them each plant, and it's resistant to many of the herbicides used commonly in agriculture. And so it spreads rapidly and it competes for nutrients and resources. And so where you would have had an arable crop, you now have blackgrass plants. And so some of the fields around here in Daventry are 99% blackgrass if left uncontrolled. And so normally farmers rely on cultural methods and herbicides. And at Utrema, we're looking to develop a biological weapon that can be used alongside these methods to increase the control of blackgrass and hopefully move it more towards in favour of the farmer and less in favour of the weed, which is spreading rapidly now. Not only is it increasing on farms and making farmers' yields drop, it's also spreading throughout the country. So it's moving further north and it's moving further west. So everyone's on the lookout for blackgrass if they haven't got it. And those that have got blackgrass are obviously looking for new methods of control. And that's what we're looking to develop at Utrema. So a biological method, when we talk about biological methods, we're talking about a fungus that infects the blackgrass and weakens it and makes the arable crop more fitter and can potentially outcompete the blackgrass. So this year we've been running 16 farm trials with the technology we've developed and the specialized fungi that we grow in our laboratory. And these 16 farms have been spraying spores on their crops. So 50 to 150 hectares in size is the trial sites. And they've been reporting back their findings. Now, this year was particularly bad because of the weather. So it was very wet since really the autumn. And so none of the farms could get on early with the spores, which was a real problem because we needed the spores to be on early because we found that the spores love cold conditions and we wanted to spread the applications out for as long as possible because we knew that farmers would be applying fungicides in the spring. And obviously any application that you make to control fungi and rust diseases in the cereal crop, like you'd be applying fungicides, would also be impacting our ability to deliver a fungus to the blackgrass plants. So we sent out the spores in little test tubes, and these could be applied alongside a fertilizer or an insecticide or anything other than a fungicide or anything that's going to kill microbes, because obviously that would kill our fungi. So things like copper sprays wouldn't be a good thing to mix them with. And then, as I say, there was a delay in application. So ideally, there would have been one from early spring onwards every 2 weeks. However, what we find is farmers were reporting that they just had to hold back on the spores. So they got applied later and then all together at once in some cases. So that was an issue. We probably got a 6 to 8 week delay on the application. So that meant the blackgrass plants were larger when we applied them. The air temperature was higher. As I said, these fungi like cold conditions. And then applied close to a fungicide. So even with those very non-ideal conditions, we still got 32% of farms reporting either having an effect on blackgrass numbers or symptoms of disease on the blackgrass plants. So that's encouraging. Obviously, 68% said there was no effect when we inquired in June. And so for that reason, we'll be repeating the trials again next year on those farms to try and get an effect. We also had a trial site at Agrivista's Lamport AgX site. So we delivered spores there, and then their agronomists and farm specialists applied the spores to the trial site there. And then I recently just got back from talking to farmers at that site, and there was a clear difference in blackgrass numbers between the treated and untreated. It was very dramatic and more than I could have hoped for, really. I mean, it wasn't a complete kill and the plants weren't all diseased, but there was definitely a difference between the treated and untreated. And if you want to see those pictures, you log onto our social media. They're on our social media. They're very encouraging. And that trial site also showed another really interesting finding, was that this wasn't a replacement for herbicide. It's not a herbicide. It's not even a bioherbicide. It works alongside the conventional herbicides. So where in that trial site they had missed out a strip of Avedex, which is the one of the standard herbicides for blackgrass, there was no difference between treated and untreated. There was just loads of blackgrass in both of those areas. So it definitely didn't replace Avedex. However, it was an additive effect alongside it. And that's a really encouraging finding. So from our grow room trials, we found that the ideal temperature was 16 degrees Celsius or below. And that's interesting because blackgrass plants, that's not the optimum temperature for blackgrass plant growth. That's above 25 degrees Celsius is optimum. This is a plant that lives naturally in Turkey in the summer, so and then spread throughout Europe. So that's encouraging there, because in the UK, when we've got these cold springs, if you go on early, there's potential there for getting the fungus infected. So the other thing we've learnt at Eutrema is about production of the spores. In fact, we've got very good at killing off the fungus, largely accidentally. So we know what kills it, we know what makes it grow, we know what makes it sporulate and things like that. So this year's been really good from that perspective. And so next year on the farm trials, we'll have even more. So we were putting on billions and billions of spores per hectare, and now we're going to have even more billions and billions of spores, trillions even of spores. So that's been a really good result this year, just simply optimizing the ability to grow spores in our lab. Another really interesting finding from the lab studies, or certainly the grow room studies, was what we found was we observed that when we watered any infected blackgrass plants, they always had loads of water droplets sticking to the leaves. Now, the uninfected plants in the grow rooms never had any droplets attaching to the leaves. So this means that the lesions, as they grow out of the leaves, the fungal lesions, they're breaking down the waxy cuticle and allowing water to go on the surface. This is great for the fungus because it allows the spores to spread and to germinate, but it can also be good for the farmer. And what we're thinking is that it could potentially massively increase the dosage a blackgrass plant receives of a foliar herbicide. So if you're applying, say, something like Centurion Max, a foliar herbicide in a non-cereal crop to control blackgrass, you could potentially get 1,000-fold, say, more herbicide into the blackgrass plant if it's infected. And that's massive, because if you think about these herbicides are losing efficacy, the plant is developing resistance to them. If you suddenly take a marginally effective herbicide and apply 1,000 times more to the plant without increasing the dose rate per hectare, then you've gone from a marginally effective to what will definitely kill that weed. And then also, if we think about, there's pressure from the water companies to reduce the amount of herbicides that are applied to crops in certain catchment areas. If you've now got 1,000-fold going into the weed, then you could potentially lower the dose rate. Now, it's far too early to suggest that we can do that, but that's one of the experiments that we're going to be doing in the lab in the second half of this year, is looking at effective dose rates and taking some of these marginally effective or non-effective herbicides, in the case of some of them, and then see if we can increase the dose that actually the herbicide receives by infecting it. So that's a really interesting area, and also leads into this whole, are we potentiating the activity of the herbicide, and then is the herbicide helping the fungus? Because any wounding that occurs is a potential. Any wound on a leaf is a site for a spore to go in. Normally these spores are looking for stomatal apertures to germinate their germinate tubes through. And then if there's a wound caused by a herbicide, that's another site for entry. So a really exciting area of study we're going to be looking at is that herbicide-fungus interaction in 2024. Another area of research we've been looking at for blackgrass in the lab is seeing if any compounds that are applied to the blackgrass plants could increase the infection on the blackgrass plant. So you'll have heard of various things that when you apply to a crop causes mildew or controls mildew or things like this. So there's various compounds. So things like spraying nitrogen on your crop potentially increases powdery mildew or rust. And then spraying molasses potentially could do that. There's a whole host of different compounds that could potentially increase the infection rate. And we've tested them all. We've tested calcium products, sugar alcohols, all sorts of things, and found that none of them increased the infection rate, which is unfortunate for this study. And actually, all they do is move the spores around and allow them to germinate on the leaf surface, but so does spraying water. So unfortunately, we've not found any of those. We've sort of ruled those out now. But we will be looking at things like UV protectants for the fungi to see if that can improve the efficacy, not by promoting the growth of the fungus, but by protecting them from the UV light in the field. And also, we've already supplied the product with dechlorinator where required to prevent this potential negative interaction of chlorine in tap water. So there's a number of areas we can look at with it when it comes to formulating the product for application onto the crop. As I say, it was a really bad year for getting fungal spores onto a crop. It's just my luck. Last year we launched a slug product in Slugger, and that was the driest spring on record, so slugs were not an issue. And then this year I launched a fungal product for blackgrass, and the fungi can't even get onto the crop because it's so wet. So what we're going to do is we're going to repeat the field trials again next year on all the 16 farms that signed up this year, and that'll be at no extra cost to the farmers. And hopefully we'll have better weather in 2024, or I won't say better weather, maybe we'll say different weather, and that will allow us to get another set of data in before we really ramp up production. As I say, I'm not going to let, even if it's a failure next year as well, I'm not going to let this one lie, because we do need a biological weapon against blackgrass. It's not an option to fail, so we're just going to keep on going, improving production, looking at different ways of controlling it. I speak to a number of farmers every week, and they've all got new ideas of different ways of harnessing the technology. So the ideas are not running out, so the project's not going to close anytime soon. We're also going to run a autumn application this autumn. So every farmer that signed up for the trials is going to get an autumn application of spores free of charge. And the rationale behind that is threefold. Is that the first is that farmers are already going on with a BYVD insecticide. So that's an insecticide that controls aphids that would normally transfer the virus BYVD to cereal crops. So that insecticide's already going on. So we can get the spores on alongside that. So there's no extra pass, no extra diesel being burnt. And so that's a perfect time from that perspective. Also, there's no fungicides going on to cereal crops at that time of year. So we're removing that worry about fungicides killing the blackgrass pathogens. That interaction we can sort of remove. And so that's a good time of year potentially there. And then if it successfully infects the blackgrass plants at that time of year, it could reduce their health, so that when they go into a harsh winter, they may die off. Now, there are also counter arguments to that. You could say, well, once it's been infected and it removes it through the winter, then it could be even more resistant in the spring. So we need to run that trial, that autumn application trial, just to see if it works. It could be that autumn application is the best application time, and we just need one application in autumn. So we've got plenty of spores to play around with now, because we've increased our production capacity, our efficiency of production, and we've been producing them during the summer when they're not going onto the crop. So we've got plenty of spores to play with, and so that autumn application, really interesting. The idea from that came from speaking to the agronomists at Agravista and the farmers at the Agravista AgX event. So really thankful to them for suggesting that. This is very much a collaborative effort, and we couldn't do it on our own, because we are plant scientists in a lab, and we need that feedback from the end users and the agronomists to sort of steer us and suggest new methods of application. So that's been really good. We might have opportunities to expand to other farms as well in 2025. So if you are interested, do sign up to the Blackgrass Biology mailing list on our website. However, whether or not new farms are taken on, it depends on how spore production goes in the second half of 2024. So watch this space really on that one. We do have 170 farms signed up to receive more information on the project, so that's really encouraging. However, we know there's more than 170 farms affected by blackgrass. So if you know a farmer that is suffering from blackgrass and they've not heard of Utrema and they've not heard of the Blackgrass Biology Group, then please do point them in our direction. So next week, hopefully Josie will be back and she'll have done all the research, so I don't have to do any research. I think it's going to be flea beetle is the first episode. Now, I'm not sure that's flea beetle in general or cabbage stem flea beetle, but hopefully that'll be of interest to all you growers of brassica crops like rape and other field vegetables, things like that. So until then, thank you very much for listening. Please do, if you could, please review this podcast on either Spotify or Apple or wherever you're listening. It does help tremendously in spreading the word and getting us to the top of the podcast rankings and getting more followers. So that would be really, really helpful. You don't have to buy products from Utrema for listening to the podcast. You just need to give me a review. That'd be very helpful. Thank you very much. Until next time, goodbye.